Today we discuss with the pilot plant scale-up technology for the liquid dosage form. When we discuss this liquid dosage form, so your syrup, emulsion, suspensions, all these come under this liquid dosage form. And as soon as we talk about the liquid dosage form, the bottle of that liquid, 30 ml, 60 ml, comes in front of us, proper labeling, carton, okay, maybe some suspending two layers or one layer, such types of images comes in front of our eyes. So exactly we have to prepare these types of dosage forms in our laboratory. Okay, what happened in our college also, we prepare some aromatic waters, syrups, or many a times suspensions. So you very well know the general procedure or lab procedure. And in lab, generally for the preparation of such types of liquid dosage form, we take ingredients. They may be a solid or a liquid, then we weigh it. After weighing, we dissolve it in suitable solvent. Okay, that solute get dissolved into the solvent. If it is dissolved, it is called as the solution. Okay, solution is a homogeneous mixture. But if they not dissolve, it is called as a heterogeneous, or there are the biphasic liquid dosage form. And in that biphasic, a standard word biphasic, bi means two phase, there are the two phases. Okay, one is liquid and one may be the solid, or there may be the two immiscible liquids. If in this biphasic liquid dosage form, two immiscibles are there, they are called as the emulsion. And if there is solid and liquid, so it is called as the suspensions. So all these dosage form we will study in this today's discussions. Generally, we should concentrate over the viscosity, the terms like the viscosity, flow properties for such types of liquid dosage form. Whenever we want to prepare a liquid dosage form, it should be easy to pour, it should be easy to remove from the container. All these properties are related to the its viscosity or its rheological property. So generally there are the Newtonian system or non-Newtonian system. In a non-Newtonian system, there are the plastic, pseudoplastic, or the dilatant type of materials are there. We should know the property of our formulation before going with such types of formulation, and we study this property during the pilot plant. So this pilot plant study is very important for every type of dosage form. So when liquid dosage form we go, it is a disperse system or the solution. Disperse means biphasic dosage form. Then we will go with the steps in the manufacturing. We already discussed. Number one is we have to collect the raw material, we have to place it properly, we have to check its quality, we have to make that this raw material we are getting is a standard one. Then next one is the liquid preparation, that is the preparation part is there. After preparation part, there is the filling part. After filling, there is the packaging. And after packaging, there is the quality assurance. Again, the word coin, there is the quality assurance. Assurance means we assure what? The quality. Quality assurance means we are getting that quality repeatedly. That is the quality assurance. Then what critical steps are the aspect we should know when we talk about the liquid manufacturing or liquid dosage form manufacturing? Number one, physical plant. In that physical plant, what is there? Heating, ventilation, and air conditioning. This is called as the HVAC system. HVAC system means there is heating, there is ventilation, and there is the cooling. So what is the meaning of this HVAC system? Throughout the plant, humidity, temperature, we have to control. And for controlling of such system, HVAC system is attached. See, in routinely in our laboratories, sophisticated laboratories, or some analytical plants, there are the air conditions are there. That air condition used to maintain the humidity and that temperature. In addition to that, in that HR system, we maintain some heating related properties also. Generally, this HVAC system is installed in each and every section of that particular company. Okay, and the temperature sometimes may vary for that area, but in production area and in a storage area, this system is very important. So the effect of long processing times at suboptimal temperature should be considered in terms of consequences on the physical or chemical stability of ingredient as well as the product. Okay. So if we maintain proper temperature, proper humidity, we can assure the stability of the raw material. These are the oral liquid dosage forms, solutions, emulsion, suspension. This is a chalk-out plan of pilot plant for the liquid dosage forms. Say, in this, this is sometimes we can say that a very complicated one, but if we go with unit by unit, so you can see that for each area they had mentioned a for each forms they mention the area, likewise the aerosols, likewise the semi-solids, there may be the liquid, there may be the solids. So these change is important for us. Okay, multiple process room is there. Then this is the control access or the entrance is there. Then facility management system, here we go with some managerial decision. Then portable equipment storage means here we store the portable equipment, means we keep equipment which we can move. Then typical ISO table suits are there. Likewise, then finished product storage, office area and finished product storage. Here we will go with the raw material. Raw material has been weighed. Then after of that raw material, we will go with the manufacturing area. Okay, we will go with the manufacturing area. These are the manufacturing area. After that manufacturing area, finished product is stored at here. Then here we can say that the control access for entrance, receiving and shipping. From this shipping we receive and it goes into the raw material. Then finished product go for the shipping. So likewise we can plan layout for this dosage form. Then this is a ray diagram for the scale up technology for the liquid dosage form. Firstly, we will go with the raw material. Raw materials are there. Then weighing and measuring of that raw material. After weighing, we will mix it. After mixing, we will fill it, and after filling, we will pack it. For mixing, we required solvents. So generally, distilled water is used. So we have that distilled water. Many a times, ethyl alcohol or mixture of it is required. So we have that special arrangement for procurement of such types of solvents, and we will use it in the mixing, then filling, packing. Then packing, there is the finished product till it get pass the quality standards. We will store it in the quarantine area. After the quality assurance, we can move for the sale. Then we will discuss about the requirement of the scale up technique for the solution dosage form. Solution means the homogeneous. So we require a big tank. A big tank is there. Okay, maybe 10,000 liter, 5,000 liter. The big tank is there for the that mixing. Okay, proper mixing. We require impeller. Okay, Impeller means instrument which we dip into that tank, and it causes a shear. Okay, due to the shear, there is the movement of the liquid, and with that we can assure the that dissolution. Then the diameter of that impeller is very important. A big tank is there, as the tank size is increased, the diameter will increase. Then rotational speed of the impeller, we have to vary the rotational speed. Many a time, if the tank is big, we have to increase. If the tank is small, we have to decrease, because if we not decrease it, okay, there may be a thrust and solution may comes out. So all these things we have to optimize during the formulation. So our tank size may be vary, but the design of tank will be same, okay, for your pilot plant and for your scale up technology. If the design is same, we can assure that that principle which we are using for a pilot plant is applicable to your scale up technology. Likewise, that impeller, maybe it is the small, but it may be its propeller. What is the how many propellers are there? Whether it is having the propeller or whether it is having the blade. So it should be having the replica for your scale up. Then uh, the next is there number of impeller, number of buffers, then mixing capacity, then clearance between impeller blade and wall of the mixing tank. All these we have to consider during the manufacturing of solution. Then height of the field volume in the tank means if it is a capacity of 10,000 liters, so for how much height, that is 6,000 or 7,000 or 8,000 or 9,000, how much we what will be the labor level for that filling that tank is we have to determine during the formulation. Then filtration equipments are there if we want to filter it. So which types of filtration assembly we will use, that we should determine during the pilot plant, and we have to develop such a big assembly for your scale up technology. Then transfer system, many a times that containers are there um, for transfer of product from one time to one place to another time. So accuracy of that conveyor system has to be developed. Then passivation of stainless steel means generally that ESS grade stainless steel is used. Then the next dosage form is the suspension. When we talk about the suspension, generally it is a dispersion. Okay, it contain liquid and insoluble solids. Then hydration weighting of suspending agent is very important. Hydration and weighting uh, uh, imparts the quality to that suspension. If that there is agglomeration of the powders, it is very difficult for us to mix it. Okay, so uh, to break that agglomerates, we use a weighting agent or hydrating agent. So it will remove that air which is in between that particles. Okay, so in place of that air, this weighting agent or hydrating agent will enter, and by this way we will separate that particles. Okay, then the time and temperature required for hydration of suspending agent. Okay, for how much time we are required, that we have to optimize. Then mixing speed, that we have to optimize for the scale of technology. Then selection of the equipment according to the batch size, means whether 1000 10,000 ml capacity. Likewise, then versatile means sorry, versatile means to avoid the air entrapment. This is a very important step as in liquid in suspension, because if there is air is entrapped, okay, it will affect your formulation, it will affect the quality of your formulation. If your drug is susceptible for that oxidation or somewhat degradation through the atmosphere, so there you will get a problem. Then the mesh size means when you are using the filtration assembly, which mesh size you are using. All these are very important points we have to consider when we talk about the formulation of this suspension in large scale. Emulsion, and what steps we have to consider during the scale up. So the number one is the temperature, second one is the mixing equipment, then homogenizing equipment, then in process are final product filters, then screen, pumps, filtering, then filling equipment, then phase volume, phase viscosities, phase densities. All these are related to that evaluation part. So emulsion means two immiscible liquids are there. So we have to reduce one part into a small globules. Okay, उसको हम लोग बोलेंगे disperse phase, जो छोटा रहता है. Okay, quantity is small, it is called the disperse phase. And dispersion medium means having the somewhat larger quantity than your disperse phase. So mixing equipment, we should have a proper mixing equipment for mixing up all the ingredient, then homogenizing equipment, then final product filters if we require, then screen pump for the movement of that liquids. So all these are the requirement for the emulsion dosage forms. Then we will move towards the semi-solid dosage form. Semi-solid dosage form consists of your ointments, cream, then majorly when we talk about the semi-solid dosage form, so its filling into the container and removal is very important. If you use a very narrow neck of your container, so it is very difficult for you to remove it. So you use the tube, you squeeze the tube, so the content comes out through the opening. Means the opening is small, but due to that squeezing, material comes out. If the creams, routinely we see that they have the very wide mouth bottles, they fill in wide mouth bottles, so it is very easy to remove by the finger. Okay, so all these things we have to consider during the scale up technology. Okay, the containers, which containers we will use, then what will be its viscosity. So for that reason, we have to mix it. So the mixer, which mixer we will use, for that reason we need a container. So what will be the container size? Then many a times if we using a ointment, so generally the waxes are used, beeswax, paraffin wax, and that carnauba wax for the lipsticks, then that cocoa butter for your suppositories. So heating is very important. Heating temperature is very important. Cooling process is very important. So if we heated that waxes or that carnauba wax or that cocoa butter, so they may change the property if it go if we heat for the at the higher temperature or it is overheated. So to prevent that, sufficient heating and cooling system is very required when we talk about the ointment as a dosage form for the scale up technology. So this working temperature range is very important. Then this product transfer is also there. We see that there are the oil soluble ingredient, water soluble ingredient. We heat them separately. After separately, we will mix it. So the proper transport is a must when we want to mix this water soluble and oil soluble ingredient. So this when we talk about the semi-solid dosage form, number one is the mixing equipment, then the which motor we will use, then what is the speed of that motor, then the component homogenization means how we evenly distribute the ingredients, then heating and cooling to avoid the overheating and charring or changing to avoid the change in the properties of that products. Okay, then at which step we will add that active ingredient, so that's why it will not affect the affected by that heating and cooling process. All these things we have to consider during the scale up. Then the in that when we go with that mixing, after that two phases are mixed, so the shearing may be there, shear force is applied. So uh, that tank, capacity of the tank, then that filling lines which we are using, all these things we have to consider. Transfer pumps in a which is attached to that filling lines. Then when we choose a pump, okay, then what we have to consider? So the product viscosity, pumping rate, product compatibility with the pump surface, then pumping pressure. All these points we have to consider when we talk about the semi-solid dosage form. Okay. Now we will go with that parenteral preparations, parenteral formulation for the scale up. Parenteral means sterile dosage form. It is free from pyrogen with its pores, free from, of course, free from the foreign materials, insoluble, solid, insoluble material, visible particles. We can say that visible particles. There are two types of parenteral preparation: large volume parenterals and small volume parenterals. Then, when we talk about the preparation of the parenteral, the equipment required in that liquid dosage form, somewhat it is same with this parenteral. The main difference is the sterility we have to maintain during the formulation. We have to grade, we have to use that SS grade instruments throughout. Also that instrument should be sterilized. So it is a liquid scale up task. This pilot plant parenteral is a liquid scale up task. Mixing is one of the important process to be scale up. See, mixing. Then mixing are of two types: large scale mixing and small scale mixing. When we talk about the large scale mixing, generally it is with that flow, and small scale mixing for the shear. If by just rotation, we go with that small scale mixing. Then when we talk about this mixing, geometric factor we have to consider. Number one is the diameter of the impeller, then diameter of the tank, then height of the liquid in the vessel, then impeller speed. All these things we have to consider when we talk about the parenteral solutions mixing. Then this is very important: sterilization equipment. Which sterilization equipment we are using during the scale up? What is the filtration equipment? Generally, these parental preparations are also sterilized by the filtration method, or the filtration is very common. At the last, this filtration method is used for the parental preparation to avoid the entry of visible particles, or maybe we can say that the insoluble particles into that dosage form. I'm saying here insoluble because it's very small particles, because many times suspensions can be is also delivered through the parental dosage form. That suspension is there for the parental. It is having the particle size in nanometer, say around 100 nanometer or less than 100 nanometer. So it will not block the blood capillaries. So for all these reasons, for the transfer and all these things, pump is again important. For when we talk about the pump, again, all these parameter, that transfer related parameter, types of the pump, pump product viscosity, pumping rate, its compatibility, its capacity, we have to study. Okay, then packaging equipment, we have to scale up that packaging equipment. In pilot plant, we will have a small packaging equipment, but in large scale, automatic machines are there, which we use for the packing of parental dosage form. Okay. Now we will go with this biotechnology derived product. This is not mentioned in your syllabus. We are studying this as a content other than our syllabus, because this is again a very important um, uh, type of dosage form which now generally uh, used in the pharmaceuticals, this biotechnology derived products. So this is not mentioned in the syllabus, but we have to know, so that's why we are discussing it. So the design and the scale of the biological process is very challenging. So which parameter we will study? So the bioreactors, there are the reactors are there, biotechnologically we have to derive. After that reaction is there, we have to filter the products, so the filtration operation. Then centrifugation, for the separation of that material we go with the centrifugation. Then chromatography, for the identification we will go with the chromatography. And then viral clearance is there. Then this bioreactor operation, that is the stir tank is there. We will